Hello, we are going to learn the chain rule for taking derivatives of composite functions today. So suppose you have a composite function like this, g of f. Function f takes points in the x-axis to the points y, and function g takes the points y to points z. Okay? So we have the function, the composite function g of f. You apply first f and then you apply g, like this. Now, what's the derivative of the composite function? How can we calculate the derivative of the composite function if we know the derivatives of f and g? Well, I use the chain rule, and I have three formulas, but this is the same equation written in three different ways. Okay? Remember, z is g calculated at f calculated at x. Okay? So this tells me that the derivative of the composite function with respect to x is the argument of the composite function, is the product of these two derivatives. The derivative of g or z with respect to y times the derivative of y with respect to x. The second formula, I'm being a little bit more careful in how I write this. This one is very good to memorize. You sort of think that you can cancel this dy of this y here, and you get dz of dx, which obviously just a memory trick. This is a whole symbol. You cannot cancel things, but it's good for you to memorize this trick. Now here, I'm being more careful. I'm saying, instead of z, I'm actually taking the derivative of the composite function at a particular point and evaluating at a particular point x0. And that's the product of the derivative of the g function calculated at f of x0 multiplied by the derivative of f calculated at x0. If instead of using this notation we use primes for the derivatives, we have the exact same formula here with a different notation. So the derivative of the whole composition, of the whole composite function calculated at x0 is equal to the derivative of g calculated at f of x0 multiplied by the derivative of f calculated at x0. Okay? I like this formula best. For me, it's the one that works. But you will also find in books the other two. It's up to you to use the formula that you prefer. The thing is, you have to understand what's going on. When we write this, we actually are meaning this. That's what you have to understand. Alright? So thank you very much. Hope you enjoy and make good use. It's very, very important, the chain rule for differentiation. Thank you.